Today we will discuss some of the problems from exercise 5.1 of arithmetic progressions. So you can see question number 2. There are 5 sections. I'll solve 1 or 2. In the same way, you can solve the other problems. So look at the second problem. It is given that A is equal to minus 2 and D is equal to 0. That is, the first term is minus 2 and the common difference is 0. You need to write 4 terms of the AP. So A1 is itself A, that is minus 2. And to get A2, you need to add 0 to the first term and it will be minus 2 again. And A3 is again minus 2 plus 0, minus 2. And A4 is again minus 2. So you can write the 4 terms as minus 2, minus 2, minus 2, minus 2. Because the common difference here is 0. Now look at the fourth problem where it is given that A is equal to minus 1 by minus 1 and D is equal to 1 by 2. That the first term is minus 1 and the common difference is 1 by 2 here. So you can simply calculate A2 by adding 1 by 2 to A1, that is minus 1 plus 1 by 2. You can add this and you'll get minus 1 by 2. Now to get A3, you need to add again 1 by 2 to the second term, that is minus 1 by 2 plus 1 by 2, it will be equal to 0. Again, to get the fourth term, you need to add the common difference to the third term. The third term is 0 and you need to add the common difference, so the answer is 1 by 2. So you can write the 4 terms of the sequence as minus 1, minus 1 by 2, 0, 1 by 2, etc. So in this way, you can write the sequences where A1, the first term and the common difference is given. So adding a common difference one time, you will get the next number. Again, on adding common difference, you will get the next number from the second term. Okay, this is the way you need to proceed. Now in the next question, that is question number 3, we need to find the first term as well as the common difference. So here is one sequence, 3, 1, minus 1 and minus 3. So in this term, we need to identify which one is the first term and we need to calculate the common difference. For that, you can easily identify the first term from the sequence and it is of course 3. Now to get the common difference, all you have to do is an minus 1, or we can simply say it is a2 minus a1. You know the value of a2, that is 1. You know the value of a1, that is 3. So the common difference of this sequence is 1 minus 3, or it is equal to minus 2. Now we'll go to question number 3, section 3. The same question, but the sequence is 1 by 3, 5 by 3, 9 by 3, 13 by 3, etc. So the first term is of course 1 by 3, there is no doubt in that. Now to obtain the common difference D, we need to subtract the first term from the second term, that is a2 minus a1, or 5 by 3 minus 1 by 3. 5 by 3 minus 1 by 3 is 4 by 3. So the common difference of this sequence is 4 by 3. This is all we have to do in the question number 3. Now to question number 4. This is an interesting question. In those sequences given below, we need to identify whether this is an AP or not. That is the question. So we'll do a simple problem first. Look at the example here. The first given example is 2, 4, 8 and 16. This is the sequence. Here we need to identify whether this is an AP or not. For that, first of all, you just write A1, A2, A3. Then you need to calculate A2 minus A1, it is 2 here, and A3 minus A2, it is 4 here. So the difference between the consecutive terms are not equal, so we can say this is not an AP. This is not an AP. Now we'll move to some other problems. The next one is 0, minus 4, minus 8 and minus 12. Here A1 is 0, A2 is minus 4 and A3 is minus 8. Then we'll calculate A2 minus A1, that is minus 4 minus 0, it is minus 4. Then A3 minus A2, minus 8 minus minus 4, that is minus 8 plus 4, it is again equal to minus 4. So in this question, the difference between the consecutive terms are constant, or the D is equal to minus 4. So in this case, we can say this is an AP. So that is our answer. Now the next problem, minus 10, minus 6, minus 2 and 2. Again, A1 is equal to minus 10, A2 is equal to minus 6, A3 is equal to minus 2. A2 minus A1 means minus 6 plus 10, that's equal to 4. And A3 minus A2 is minus 2, minus of minus, again plus 6, it's again equal to 4. Here also, the difference between the two consecutive numbers are a constant, and that is equal to 4. So we can say the common difference of the sequence is 4, and this is an AP. Okay, this is also an AP. So these were simple problems. Now we are moving to certain difficult questions. Okay. So one question is A, 2A, 3A, 4A. This is the sequence. Now here A1 is equal to A, A2 is equal to 2A, and A3 is equal to 3A. You need to calculate D 2 times using A2 minus A1, that is 2A minus A. 2A minus A is simply A itself. And again A3 minus A2. You know the value of A3 is 3A and A2 is 2A. Now again 3A minus 2A is A. So you can see here the difference between the consecutive terms is a constant and is A here. We can say D is equal to A. So this is also an AP. Now here is the next question. The sequence is A square, A cube, A raised to 4, etc. In this case, the first term is A, second term is A square, and the third term is A cube. Now A2 minus A1 means A square minus A. Now A3 minus A2 means A cube minus A square. If you want, you can take an A outside and it will be A square minus A again. You can look at this and this term. Here it is A square minus A, and here the difference between the two consecutive terms is A square minus A into A. So we can simply say these terms are not equal. So we can say D is not a constant, or the difference is not a constant. So this is not an AP. We can conclude that this is not an AP. So that's it. Now the next problem is root 3, root 6, root 9, root 12. Root 3, root 6, root 9, root 12. In this case, the direct access is a bit difficult. For that, just try to obtain in terms of root 3. That is what we have to look at in terms of root 3. So we can write here A1 as root 3. Now A2 is equal to root 2 into root 3, or we can write like this, root 2 into root 3. Now A3 is equal to root of 3 into 3, that is root 3 into root 3. Now from here you can calculate A2 minus A1, that's equal to root 2 into root 3 minus root 3. You can take a root 3 common outside. Now within the bracket you will get root 2 minus 1. Now we'll calculate A3 minus A2, that's equal to root 3 into root 3 minus root 2 into root 3. So here also you can take a common root 3. Now within the bracket we are going to get root 3 minus root 2. So you can simply say that these two factors, that this term and this term are not equal. So we can simply say this is not an AP. One more problem we'll discuss from this exercise, and that is a root 2, a root 8, a root 18, root 32. Again, the first term is root 2, second term is root 8, third term is root 18. You just try to reduce these two terms in terms of root 2 if possible. So on division with 2, it will be 2 and 4 here. So we can write root 8 as 4 root 2. Now again root 18. Root 18 on division with 2, it will be 9. So we can write it as 3 root 2. So first term is root 2. Second term is 2 root 2. Sorry, it is 2 root 2. Here it is 4. So 2 root 2. Now again here it is 3 root 2. We can calculate A2 minus A1. We know A2 minus A1 is 2 root 2 minus root 2. 2 root 2 minus root 2. If you want, you can take root 2 as a common and you can write 2 minus 1. 2 minus 1 is 1 and it is equal to root 2. Now A3 minus A2 means 3 root 2 minus 2 root 2. Again root 2 common within bracket 3 minus 2. Again 3 minus 2 is equal to 1 and this is equal to root 2. So in this sequence, the common difference is D, a constant, and D is equal to root 2 here. So we can say this is an AP.